Thanks for coming. It's a summertime, but you guys are still here. That's good to know. And also welcome to those who are online. And I believe this is really the time for us to enjoy in summer. But of course, there will be some other learning opportunities for everyone. And so I'm glad that you guys are here. So my name is Gary Wong, and I'm from the Faculty of Education. And also today we're very honored to have Dr. Bowen here from the University of British Columbia. And she's visiting us and trying to give us these seminars on the feedback loop, informing and supporting students' teams. So let me just say a few words about our speaker today, and before I turn the time to Bowen. So Dr. Bowen is an associate professor of teaching in computer science at the University of British Columbia. She has been developing novel learning technologies that maximize students' learning outcomes in computer science education contexts. Recently, her lab builds a team formations and analytics tools called teamable analytics, which accommodate varieties of team formation scenarios and criteria. The software has been used in over 33 interdisciplinary classes across universities, and it won the Best Demonstrations Award at the International Learning Analytics and Knowledge LAK Conference in 2022. So for those who have been doing works in learning analytics, I'm sure you're familiar with this conference, which is very famous. And currently, Dr. Hui's labs is working on expanding this tool with team analytics for monitoring to support effective teamwork. Dr. Hui received the UBC Professor Award for Teaching Excellence and Innovations in 2022, the Computer Science Canada Award for Excellence in Teaching in 2023, and the UBC Open Educational Resource Excellence and Impact Award in 2024. So, 3 years in a row, which is very nice to see. So without further ado, let's welcome Dr. Hui for the kind of program.
Thank you. 好多謝咁多位今日嚟聽呢個演講，好多謝香港大學邀請我今日嚟發言。Thank you, University of Hong Kong, for inviting me to give this talk today, and everyone for attending this talk. Let's see, let me make sure I navigate this. Okay. So I've been working on technology-enhanced personalized learning for quite some time now. And initially, I started working on it in the individual context, trying to see how we can help individual students learn and maximize the learning outcomes. And more recently, I've actually been focusing more in the team environment and looking at collaborative contexts. So as Dr. Long mentioned, that I worked on teamable analytics, which is a team formation and analytics software. And these are just some of the highlights of the things that we've actually looked at as part of the software. So I won't go into each one of these items, but I'll give an overview later on in more details. The pictures that you're seeing here, this is a team of the amazing students who have been working on these different aspects of this project throughout the years, and you can click on the link and follow the links and the QR code for more details. And as mentioned earlier, this is an open source platform, and it's been used in over 39 interdisciplinary classes that you can see. So why teams? I'm sure most of you know that teamwork has shown a lot of positive learning outcomes, such as increasing productivity, encouraging personal growth, and promoting innovation in teams, and also allowing individuals to build strong relationships. And of course, teamwork is a really important skill, and especially in the 21st century in both educational and work-based settings. And so when we talk about forming teams, the actual task of team formation I'm going to focus on is thinking about in a classroom setting where we have to assign all the students in non-overlapping groups. And I mentioned this because there's actually different variations of the definition depending on the field that we're looking in. And so sometimes this is called team formation, this is called group formation, this is also called team assembly in the literature. And here what I'm trying to say is also, if you are trying to allocate all the students within a classroom to the different teams, and you're trying to find an optimal solution where everyone is happy with the current context, finding an optimal solution is an NP-hard problem, and it's been shown that it's actually computationally infeasible to actually solve that problem. So a lot of people, what they do is find instances and subset and simpler versions of those problems to solve, or finding an approximation algorithm to solve that problem properly. Okay. So some of the current approaches that people take to forming teams in their classrooms, the most common one is definitely random. So the problem with this is that there is no consideration of preferences or skills or individual needs to making sure that the teams are balanced in any way. Instructors often also ask students to form their own teams because it's easier for them to not have to manage all the administration. However, students often make friends with people who are similar to themselves in terms of their skill set and things like that. So then you end up having unbalanced teams. And there's also ways where some of the instructors will try to manually form teams strategically by considering certain types of criteria. But because of the manual work that's involved, and there's a lot of different criteria that people can actually use, this usually only works in smaller classrooms. Okay, so in terms of classes that are beyond, say, like 40-ish students, you really need an assisted software tool to help with this problem. And so some common software that's out there is Grumbler, you might be familiar with, or at least maybe have heard about. But Grumbler is basically a spreadsheet. So it does a lot, it's very powerful, but it's got a spreadsheet interface. And so unless you are really comfortable working with numbers and a lot of numbers and just trying to sort of figure out where everything is, it's actually very complex to figure out how to use it properly. And because of the spreadsheet, it's really generating the teams and then it's done. So there's no peer evaluations, there's no ongoing support for your teams. The other one that is very famous is CAPME. And this one used to actually be available for free. So it was developed in the early 2000s, but over the years has now become a cost, like a paper service that you actually have to buy into. It's got a fairly complex UI only because it was developed in the early 2000s, so the technology is not super friendly in terms of how we use it. It has some peer evaluation, self-evaluation support, but once the teams are generated, you cannot modify it for any reason. So as the instructor, basically you put in the input criteria to generate the teams. If you don't like what the software is doing, you can't really, augment it or change it in any way. It does some analytics, but it's very limited. It's actually very difficult to actually tell from the documentation what's available. What's common between these two is that neither of them are integrated with your learning management system. And so the instructor would have to import the students. And by doing this, it causes extra overhead, but also there's some data security issues involved. Right? And both of these also, they focus a lot about diversifying student characteristics. So there's a lot of emphasis about trying to bring different people who think differently together. So then it fosters more innovation, fosters more learning from each other. But it doesn't do anything about clustering. And so if you wanted to, let's say you had a classroom with different campuses of students working together, and you wanted to say, okay, let's form groups with people from the same campus, you actually can't do that because you're trying to group people together and you're not trying to diversify them. So likewise, another problem is time zone, right? If you want to group people together with based on similar time zones or similar timetables, you can't group them together. So these tools are really just for diversifying and splitting characteristic stuff. They also do not handle project to skills matching. So if you have specific projects that have certain requirements or certain hardware devices that are needed, and let's say, let's say like one project requires you to have a Windows machine, another project requires you to have a Mac machine. It won't actually be able to say, okay, these students have Apple machines, so let's put them into these projects. It actually can't do these skills to project matching. Okay, does that make sense? So the very basic use case here, unfortunately you can see some of those lines, so ignore some of the faded lines, but the basic team formation use case involves these steps where the instructor is initiating the formation of the teams. And so in order to form teams strategically, they're actually setting up the elicitation process. Say like the questionnaire, these are the kinds of things that they want to consider into forming the team. So they might ask you information about their demographics, background, skill sets, things like that. And then it will set up a questionnaire and then the students will come and fill this out. So that's the second step. And once the information has been filled out, you can gather that information and the instructor can define certain criteria that's important to them to then form the teams automatically or manually. Okay, so this is a very basic team formation step. Okay. So in terms of the actual team formation generation process, there's a lot of different algorithms that's been proposed in the different fields, and these are the major areas. So CSCL, computer supported collaborative learning, has a lot of algorithms there that's been proposed. Also, you'll see a lot of literature in the AI areas, as well as some algorithms that's been proposed in specific educational fields. So just to give you a quick highlight, so in the CSCL area, just between 2014 and 2019 alone, we found 5 literature reviews reporting all the different work that's been going on in this area. And so the general patterns that have been reported in these literature reviews include reports saying that the educators consider a wide variety of learner characteristics that are being used to form teams. So it could be gender, you know, you might want to mix genders up. You might want to mix like different cultural backgrounds or language differences. You might want to mix like the way people are thinking in terms of their cognitive styles. And so by and large, the focus is on diversifying learning characteristics when they're forming teams. Although there's actually quite a lot of a mixture of trying to create heterogeneous and homogeneous criteria and mixing them together. Okay, so not only using one criteria, like I want to put all the girls across all the teams and spreading them out, but you know, maybe it's a combination of that and considering the timetables and considering their cognitive thinking styles and so forth. So multiple criteria is very common. They also report that there's a lot of algorithms that's being used, a variety of AI and machine learning approaches. There's no general patterns, but what's important is that they're saying that from these literature reviews, they're finding that a lot of these algorithms are often not implemented. So they get proposed in terms of just the algorithms in theory, but then they don't necessarily have evidence to have implemented them. There's also a lack of evaluation for those that have been implemented. So they talk about how long it takes. You know, some of them take hours to actually run for a classroom of 20 or 40 students, but they don't actually evaluate how well the teams are being formed. And furthermore, there's no comparison of these algorithms on their relative effectiveness. And that's largely also because these algorithms are not open source. So once they publish something, they don't necessarily share the code so that other researchers can implement it and compare it with the new ones that they develop themselves. So these are some of the problems that are in the literature right now. And in terms of diversity, we found one paper that was reported from these literature reviews in 2017 that uses gender and language as criteria, but they don't have any metrics to evaluate how well the teams are formed. They don't actually diagnose it. Basically, a lot of these studies, they talk about, here's an algorithm, they apply it to a class, and then they show you the teams that get formed, or they actually talk about, oh yeah, students seem very satisfied, but they don't actually show you like, what is the actual composition of these teams, okay? And so in this particular paper, they talk about, they show you the list of the teams that are formed and the individuals that are in them, and they actually show that sometimes there are cases where there's problems with tokenism. So there's like a minority student stuck in the team by themselves. And so if you think about that situation, like if diversity is so important, it may be the case that we don't want to tokenize minorities because that might cause additional dynamics in their collaboration. Okay, so these are just some things to keep in mind. And then in terms of AI, there's also several areas of research. By and large, the AI areas focus more on hardness results. And so, they talk about NP completeness, they talk about computational feasibility, fairness, those kinds of results. And so the ones that's most similar to CSCL work is group activity selection problem, which looks at assigning individuals to groups based on the preferences over the groups. And by preferences, they're using utility. So a formal way of defining individual preferences and looking at what their preferences are over the groups and then over the actual potential teammates that may join with them. So a lot of those comparisons, and so they're trying to find optimal solutions, and they're looking at individual preferences, but they don't really consider projects to skills matching in this case either. There's another area that is kind of the opposite, which is team formation problem, and this is more in the optimization space, where they're looking at a possible individuals, possible set of individuals, and then they're trying to select a subset subset and find the group that makes the best team to tackle a particular task. Okay, so their focus is the opposite, where they have a task they want to solve. There's specific requirements about that task, and they're trying to find the people with the best skills to solve that task. Okay. They also consider minimizing communication costs between the team members. And so communication costs, you can think about like, if you're better friends, maybe you don't have to communicate, but the cost may be smaller. So you can think about it as like social preferences as well in that case. However, this problem is more of a simplified problem because in a big classroom, our setting is we have to allocate everyone into teams. In this setting, they're actually saying, here's a group of people, and we're only going to pick the best 5, for example, that solves this problem for us. Okay, so this works better for a workplace setting where you're actually trying to find the best team of individuals and you don't have to allocate everyone to a team, to different teams. So it's a simplified version, but subsequent work has also worked on what's called a multiple TFP problem, which they now actually look at multiple instances of this. And so it's still not exactly what we're trying to do, because what they can do is they can solve one instance, that you can look at multiple projects and try to split everyone up into these different teams as multiple instances of the team formation problem. The problem is that if you have one person who's really good, who's able to solve all possible tasks, what happens is that this kind of solution in the multiple TFP space will actually pick that one person as part of that team for the first task. When they're done, then they'll pick that same person, they'll reuse that person and do, the second task. And then when they're done, reuse the third, for the third task and so forth. So it's not the non-overlapping groups that we're interested in a classroom setting. Okay. And also for simplicity, because of the computational complexity, the model also is limited to every individual having only one skill, which is very unrealistic. Okay. And then in the AI area, the last one that we found that's been worked on quite a bit is called fair division. And so they're trying to think of it as a resource allocation problem and try to assign resources to agents with the emphasis of trying to be as fair to all the individuals as possible. And again, it's a very, the formal framework is similar to the first one where they're actually using utility functions. So one of the algorithms that's been fairly robust is called the double round robin, so DRR, where they actually showed recently, and it actually does a pretty good job in terms of how well it scales up to large classes. And what it does here is it actually can create an MV free up to 1 allocation. So MV free is, the concept of MV free is like, if I give you resources, and this is an allocation, I give resources to everybody in a classroom. In order for it to be MV free, nobody will envy someone else's allocation. Okay, so MV free up to 1 is basically MV free with 1 exception of an item that you might envy. So it's a bit of a relaxation because of that, because MV freeness is quite difficult to achieve in large settings. We took that idea and we implemented a greedy implementation of it, which basically means it's an approximation algorithm, so it works a lot faster, but it is not exact and it is not optimal. So I won't go into the details of that, but we model students as resources in this particular approach. And we allocated students to projects by weighing against their social preferences and diversity constraints via utility functions. So we basically took the different flavors of the AI algorithms that considers project skills matching, that considers project preferences the individuals might have in terms of project rankings. We also took social preferences because you might need to be with your friends for security reasons, psychological safety, those kinds of aspects. You might need to avoid, being with enemies. So we have some of those social preferences considered here. We also took ideas from the GAS literature and the CSAL literature about diversity constraints. And so basically we used the utility framework that was used in the AI work, but we elaborated on the utility function by considering these 4 different types of criteria. And this picture really just shows you that these different types of criteria have percentages and allows the instructor to ideally weigh which type of criteria is more important to them when they're forming the teams. So we generalized it to encompass these different aspects. And then we showed using benchmarking results in simulation that our approach outperforms state-of-the-art AI algorithms. In terms of things like speed, MV freeness up to 1, as well as activity cover. So activity cover just means that the projects that are defined have certain requirements, and we assign people that were able to complete them successfully. Okay, so in terms of that percentage. So in simulation, it looked great. Then we also ran some pilots with different class sizes, and it was actually quite promising as well. We had some positive results for student satisfaction in terms of their self-reported satisfaction, as well as activity cover on the projects that were actually assigned in these pilot studies. However, we learned quite a bit in terms of the actual practicality of how we use these algorithms. So one thing we found was that instructors need to augment the generated teams. So once your AI software generates these teams for you, the first thing they do is they really want to diagnose if this is done correctly. Okay, and then if it's not, then they want to augment it. So thinking about the team formation software and the algorithm, as much as that's really difficult work, that's not the end of the story. Okay. The second aspect is we did these pilots through a script, and so we heavily supported the instructor. No instructor is ever going to want to run these scripts, and so you need a user-friendly software to do the front end so that it can actually be generally used by other people. And that still, even though as much as it's general and it covers these different aspects, there's still some specialized cases that we've identified that are actually very difficult to meet. So there's other work that we're actually looking at to see, what are these different cases and how do we actually handle them. So stepping back to the general picture of the team formation use cases, what this actually tells us is that after these teams are generated, the first thing that we actually have to do is to allow a part where we have the instructors be able to adjust the teams and augment the teams. So in this case, we want to be able to support the instructor be able to diagnose whether the teams are formed satisfactorily. And it could also be, due to cases like registration. Sometimes after you form the teams, students drop out of the class. And so you have to change the teams, and you still want them to be balanced. And so if all of a sudden, you intended for all the teams to be 5 students, but 2 students dropped out of one team, you might want to rebalance them somehow, right? So there has to be some ability for the instructor to make these manual changes. There's also sometimes like unsolicited information or personal requests that came up in these really specialized cases. One extreme example that we have encountered is, for example, after we formed the teams, one student came up to us and said, you know what, I don't want to be in the same team as this other student because there was a previous harassment case that has happened. And so we have to respect that and we have to split them up, right? So those kinds of things come up. So there has to be some flexibility in the software to accommodate these kinds of cases. The other thing is the software should allow for peer evaluation. So this basically extends the use cases so that the instructor should be able to set up some kinds of peer evaluation to support the students' ongoing performances. And once that's set up, then the student should be able to complete that information. And furthermore, that information could then be used if the instructor is actually generating teams multiple times with the same cohort of students. So that doesn't happen all the time, but it happens from time to time in certain classes where they have multiple projects. And then they are actually trying to make sure that, well, let's not have the exact same students to work together, or they want to have some overlaps. So there's these different kinds of cases that have come up for us as well. And so we took these different cases and packaged it as teamable analytics, and this is the software front end that you see here. At the top is basically the different steps that are similar to the ones that we identified in the general use cases, and so you can specify the students, make sure they're important, the important attributes that you want to elicit if projects are involved, creating the surveys to elicit that information, generating the teams and setting up the criteria, and then doing peer evaluations. So this was submitted to the Learning Analytics and Knowledge Conference in 2022, and we won the Best Demonstration Award. And so these are just different visual analytics to help support an instructor diagnose whether a team is formed according to what they want in the criteria. So rather than so imagine, when you're using the software to help form form teams in your class of say 200 students, and it finishes, generating these teams, the first thing it does is spit out a list of student names. Well, the chances are, in the beginning of the semester, you don't know who these people are anyways. So there has to be some better way for you to diagnose whether the teams are formed the way that you wanted them to be formed. And so we use some of these analytics to support that task. The tool is integrated with our campus learning management system. So basically, through your course shell, you can connect to it directly. And so it eliminates some of the overhead that an instructor would have to do to set up, and also provide some of the data security. And of course, like, team formation is just the very first step. What we propose is that there's actually, more that's needed when we're trying to support students. So earlier I mentioned the use of earlier I mentioned the use of peer evaluations, so self-evaluations and peer evaluations. And basically, after the teams are formed, students work together, and then you can collect some subjective feedback from them, right? And so this process forms this loop here. And so this overall loop actually basically gives us information about how teachers can form teams multiple times with the same set of students. And we can use peer evaluation feedback to do future team formation. So this forms one of the loops that we're interested in terms of the feedback that we can collect from our students. The second one that we mentioned, where teachers access as the audience for the learning analytics feedback loop, is after the teams are formed, we want to allow them to engage in this team composition diagnosis process, so that they can ensure that the teams are formed the way that they want them to be formed. So the third aspect is, of course, while the students are working in their teams, we want to be able to monitor their ongoing performance and behaviors in case any problems come up. So not only are the teachers, receiving, like, the audience of the learning analytics feedback support, we actually want to care about, like, how we can provide support for students as well. So this is a third loop that we've started working on recently. And you can imagine things like potentially trying to observe the kinds of activities that are going on here. There's a lot of collaboration dynamics that's been studied in this area. And so in theory, we can try to do some kind of prediction to see how well the teams are working together. And if we can figure out these teams are at risk, then we can better support them and intervene with appropriate mechanisms. Okay. So that's the idea. And so we started looking at this to see how hard it would be to do, because we thought this was a very hard problem. And so we wanted to see, like, what are some of the key team concepts that are out there. And there is so much in the literature, like so much that I can't claim this to be exhaustive, but this is quite extensive. We've gone through quite a lot of literature, and we try to categorize them in these three different areas. The first is about team stages, and the most popular ones that we came across is team stages of development, the tokenism model. So you're probably familiar with this if you're looking at teamwork, where they talk about teams working in, when they first get together, they're forming the teams. And then there's also the way to establish how they work together. So the norming stage, and then the performing stage, and so forth. So these are the different stages that the tokenism model talks about. One of the criticisms is that they're focused too much on identifying which stage they're in rather than, when they need help and so forth. And so there's literature that tries to simplify it into a two-stage group development model, which is the other one that we're identifying here. There's also a lot of literature that talks about what are the important characteristics to have a successful team. Okay. So I won't go over all of these. There's actually a lot of overlaps. Sometimes the literature uses different terminology, but refers to very similar concepts. And by and large, though, like, if you try to categorize all these different characteristics, they are either talking about individual characteristics that are important, like maybe you need someone who has certain leadership skills, or they are talking about the team level characteristics, so either individual or team. So the team may, have characteristics that emerge after they work together at a certain level. So trust is an example of a team level where, individuals within a team will trust each other. So this literature that we reviewed so far has been very descriptive. They talk very much about what they think is important or what they think will contribute to successful teamwork. But in order to get to the point where we want to build predictive teamwork models, we have to build these computational models, which cannot just be descriptive. So we have to get at the very quantitative side. And we were only able to find a few works that actually touch on quantitative models of teamwork. The first one is the CARE model. And then the second one doesn't really have a name because it was kind of like an isolated paper. But it actually tries to do some of the prediction based on the data that it collected, but it was an isolated case study. The first one is the CARE model, where they collected a lot of data, but it's based on a questionnaire that they would give to teams of students. And based on the results of the questionnaire, they would identify where you are in terms of the different aspects of care. So education and reliability and adaptability of the teams and so forth. So they look at those different factors. The questionnaire itself is still quite descriptive. So there's still a lot of work, a lot of gaps that needs to be done in order for us to actually build these collaborative models for prediction purposes. So then the way we summarized it was we took the different concepts and we tried to synthesize them in terms of these different team concepts. And so we found 6 overarching categories, and each one of them, I expanded the trust one, have associated sub-concepts that we found in the literature that we grouped them together. So in this example, trust is the broader name that we gave it, the overarching name, and then the subcategories, like the sub-concepts include safety, belonging, commitment, and so forth. Okay. So just to give you a quick example of what commitment might look like, we try to build, we took a couple of these concepts and we built a computational model. And the reason we did this is because we wanted to understand what does it take to build such a model? How do we tie the literature descriptions and the literature findings into these models? And what data is possible to feed in? And what data do we need to collect in order to build such a model? Okay. So the example I'll talk about is commitment, which is more about an individual's commitment to the team, but we also looked at shared mental model, which is a team level concept. Okay, so we use dynamic Bayesian modeling approach to tackle this modeling problem. You can take your favorite mathematical framework, but this one we liked because it gives a very intuitive way of reasoning about the different factors that are involved in a model. And it's a well-established framework, and it has it has a lot of the probability foundations to actually let you do inference and predictions with the model that's been built. Okay. One of the nice things is that once you build these, you can actually build them at the team level or at the individual, and you can personalize it based on the parameters of the model. So just as a simple example, you can imagine commitment as a core concept. And so this is what this node represents. And you can imagine that commitment might be related to enthusiasm. So if you're highly committed, you might be extra enthusiastic about the work. Or if you're highly committed, you might also want to take charge and actually want to lead more aspects of the work that you're doing. Okay, so that's what these variables are meant to represent. And each one of these arrows represent the relationships across the different factors. Okay, so these dynamic Bayesian models have 2 aspects to it. One is a graphical version that has the picture that shows the nodes and the edges. So you can actually think more about the relationships between the different variables. But it also has a quantitative component. And so this is an example of the conditional probability tables that just shows you the probabilities that are underlying the models. You don't have to really know all the details about it, but it gives you some relationships about what the dynamics are underlying each one of these variables and these relationships. So for example, this just says that the probability of a person being either lowly committed or highly committed to the team is just 50%. So it's just 50-50 in this case. Okay, so anyone has 50% chance of not being committed to the team. And in this case, because there's a relationship here where enthusiasm is dependent on the commitment level, this table gets a bit bigger, it's a bit more complex. And so this one particular probability here just means that the probability of someone being not very enthusiastic, or sorry, the probability of someone being enthusiastic when the person is not very committed is only 10%. And if you are very committed, then you are more likely, you're like 80% likely to show your enthusiasm. So it just talks about this, right? In terms of how likely you're going to show these sorts of behaviors. And then this table gets a bit bigger because it's got two different relationships that are related to it, but you can think about those numbers in a similar fashion. I wanted to mention, the nice thing about this is, after you put on all these numbers and all these models, what you're able to do is, once you establish the model, you can ask interesting questions like, if the student is highly committed, how likely are they to take charge? Okay, so you can start asking these types of questions based on the variables that are involved in the model. And also you can think about things like overtime. So you can extend this to multiple time steps. And then you can think about this in terms of asking questions like, if the student is highly committed, how likely are they going to stay and continue being highly committed next time? Okay. So we can start thinking about, like, rather than thinking about the guts and details, after the model is built, we can use it in a really meaningful way. So we try to build this, right? And so what we're trying to do is, rather than we just sort of build this from scratch, we took the literature findings, which are sentences like this, where we found in the literature feelings of responsibility for the team's work. And then we try to create the relevant variables and try to identify the relationships with these sentences that are in the literature. So there's a lot of assumptions, a lot of gaps, but that was our first step. And this is one of the things that we identified to be a very difficult thing to be able to do, right? Is to bridge that gap between the literature findings of the models, of the decades of research that has gone into team modeling, and then trying to actually build a computational model. And so here we have commitment. You can think about someone being very highly committed, medium, or lowly committed, and they might have certain kinds of behaviors, like they complete the amount of work that they complete, or how enthusiastic they are, whether they go above and beyond, rather than just doing what they're told to do, and then whether they take charge and lead the team. So those are the kinds of general behaviors that we saw from the literature, and then that alone is still fairly high level. For the computer to actually be able to make better predictions, you have to take these and expand them into data that you can collect. So the kind of data that you can collect and observe from individual people working in teams are actually very fine-grained and very detailed, like whether specific tasks are done on time and how many tasks are done on time. So everything in these double circles are things that we can potentially observe, right? And so work that is being accepted by other teammates. We have things like, when they're talking, they're exerting positive tone, or they're just being very negative all the time, those kinds of behaviors. Whether they actually bother to initiate conversations or just responding to things. And, the main point is that there may be more depending on what platforms you're using. But the main point is that for the model to be able to make these reasoning with these kinds of questions that we're interested in, and to be able to reason whether the person is highly committed to a project, you have to be able to tie them to observations that we can gather data for and that we can see. Okay, so then the data can propagate and the probabilities can propagate back up here, and then we can actually ask those commitment level questions. So this one sentence, for example, that we found in the literature, where they're saying, when they're not very committed to the project, they have things like missing deadlines and letting teammates down emotionally. So that one sentence alone will have an impact on, okay, well, they're missing deadlines, and so they're not really doing much of the work on time. And the work is not necessarily accepted by the teammates. And, letting teammates down emotionally, that might be the way that they're expressing themselves, and there's a lot of negativity in the way people are talking. Okay. So once we built the model, what we did was just to show in simulation what this might look like. And so this is just a quick example. If you think about all the different data that we can collect listed along the bottom here, so this is task all the tasks are done on time, some of the tasks are done on time, or none of the tasks are done on time, and so forth. Okay, so these are all the data that we can collect. And this is a histogram of the type of people that would show the different kinds of behavior when they're not committed. And the one above is a histogram of the type of people that would show the behaviors of those who are highly committed. Okay, so we took our model and we got it to sample a bunch of data out over 13 weeks as if they are working on a project for 13 weeks in a row. And then we sampled it over 100 average trials, like trials averaged over 100 weeks. Sorry, 100 times. And so we're just trying to collect average data at this point. And generally what you can see is the kinds of behavior where there's high values here. So we're seeing a lot of high observations in terms of a person who's highly committed, completing the work, and also the work is accepted by others and so forth. Where it's high in terms of frequencies of behaviors up here, it's low down here. So someone who's highly committed, the kinds of actions and behaviors is kind of like the mirror opposite of someone who's not very committed. Okay, so it's not exactly like that, but it's it's very similar. So just to highlight a couple of examples. So these two here on the left indicate that the person, a highly committed person, is more responsible because they're doing work on time and they show good quality work. Whereas the circles here on the right side is showing more about their leadership qualities. So they have more actions that are about assigning tasks or initiating meetings and making sure that the team is on track. So once the model we built made more sense, we started to step back to see what kind of data do we need and how do we even go about collecting this data. This is again a snapshot of the model on this side. So we had to identify, we used the literature to help us identify the different variables that are involved. And there's also those number parameters, right, that I talked about earlier, those probabilities. So those ones are really tricky to collect. And this is basically some of the ideas that we can try to collect that information. So at this level, to actually know how many people tend to be committed to the projects or when they're committed, whether they show enthusiastic behaviors, the easiest way to do this is through surveys. There may be some ways that, maybe a teaching assistant or a teaching staff can collect that information as well based on their weekly observations, but it's still very subjective. Where we can actually collect more objective data is down here when we actually have data that we can collect from certain platforms that we can see how people behave. And so, for example, if you know that certain students are very committed to the project, you can start counting how often do they initiate meetings or count how many times they're reviewing other people's work and so forth. So we're going from a lot of subjective data to only these ones where we can actually rely on some more objective type of data that we can collect. And generally, if you look at all the different kinds of data in teamwork, we can think about them in these three ways. So one is activity level data, where we can look at task completion, quality of work, and those are the easy ones that we can observe, and those are the easy ones that we can really collect because we can see people submitting work. And the nature of that work. Interaction is another type of data that's very common in teams, right? Because we have different people working together. And we want to see things that, well, maybe we can see how they are reviewing each other's work or whether people are exerting positive and negative tones when they're talking to each other. These ones are a little harder to collect data for because it requires insights into the communication. And a lot of teamwork is not, a lot of team communication is not very easy to collect in a natural way because we often just talk to each other. So unless you're constantly recording what everyone is saying all the time, it's impossible to collect this in a natural way. So some of the literature puts teams together into a room, lock them up for an hour, do a control setting and get them to work on a task together. But for 1 hour, you're not really a team. You really have to form that team over weeks and weeks of interaction. And when you're in a lab control setting, you don't necessarily naturally talk to each other, right? Because someone's watching you, you're being videotaped. So it's really tricky to collect this kind of data. And then the last type is project management tasks. Whether they're assigning tasks or managing progress or facilitating meetings and who's doing this type of work. And this can be a mix of the two. Like you can potentially use some kind of project management platforms to help collect that information, but still, because we are if we're working face to face, we are often doing these in terms of verbal communications. So it also becomes a bit difficult to collect as well. So one of the things that we did recently was to look and see what we can reveal from looking at people's interactions within the teams. So we started doing this recently, and one of the things in computer science we do a lot is to do programming development in a platform called GitHub. So this is an open source platform where we do a lot of programming together. And so the idea is that if we have a lot of team data, we can try to collect data from GitHub and see how people interact with each other. So just based on the GitHub interaction data, what can we reveal about these teams? And so we're looking at GitHub as an environment that provides these natural collaboration activities where we're not monitoring and micromanaging all the teams. So this is the overall architecture of the data that we, of the system that we built. This part basically is taking all the data that we can grab from GitHub and processing them in different ways and into meaningful chunks. And then this part basically takes in peer evaluation, so more subjective feedback from the teams, which doesn't necessarily have to live on GitHub. It could be like surveys that you're asking students, and we're also just combining objective data that we can collect from GitHub with subjective data that we're getting from students as well. And together, this gives us these reports with the analytics so that we can actually get insights about how the teams are interacting. So in peer evaluations, for example, you can imagine a lot of students might say, oh yeah, we work really well together. And then you can see like in terms of the actual programming that they're doing, well, maybe they actually don't like each other's code, right? And so they're always rejecting the work. So you can see like if there's actually coherence in the data that you're collecting or if there's conflicts in terms of the story that people are telling. And so these reports are meant to give us a team analytics to help the instructor diagnose how well the team is behaving and how well the team is working together as they work from week to week. So this part is in progress, is under review, and I'm going to focus a bit on this work that we looked at. One of the things that we do in a software programming environment is imagine in a project where there's a lot of different work that we have to program. You don't all just sit there and program together. It's like writing an essay. You divide up the different sections and then you go off write, and then you come back and you merge them back together into one single essay, right? So the software programming projects are very similar. However, when they are merging, there's a specific protocol that requires them to review the code of each other's work before it gets merged. So if I went off and wrote this part of this essay, in order for it to be integrated into the final essay, other students in the team must review and make sure that this is written properly. Okay, so we have that process. This is called the code review process in programming. And so we're looking at that data to see how things are like how the team dynamics are actually going to pan out with the student teams. And the reason we're interested in this is because of the diversity that happens in the teams, because what kind of goes back to what I was mentioning earlier about diverse teams, that people are very interested in having different students work together. But if they're not formed properly and you have a lot of token minorities, it becomes a problem. So while many educators agree that diversity in teams is really important, there's actually a lot of conflicting results about the team outcomes and how diversity is defined. So diverse teams don't always give good outcomes. And so you can actually look at specific cases as to when they generate positive outcomes and when they don't. And we want to be able to support them properly in that case. And in particular, when you have gender diverse teams or racial diverse teams, the literature has reported issues where the minority members are often confronted with microaggressions. And they're also often perceived as less skillful than their peers in homogeneous teams. And they're also treated with bias. So often they're not heard, not given leadership roles, and pressure to change behaviors that are stereotype of their own identity. And these problems are often exacerbated when minorities are tokenized, so when they're the only single female or the only single Black person or something like that in the team. Okay, so if we can identify and prevent some of these issues, we can better support the teams. So this is the software engineering team collaboration environment that I mentioned, where we're focusing on the code review process. And in terms of the literature that studied this type of work, the literature reviews certain issues that are found with gender diverse teams, but in the professional settings as well. But there's actually very little work done in an educational setting to see how student teams are working together. So we'd like to actually be able to see if some of these results are also replicated in the educational setting. And also, there's also work that should be done on other aspects of diversity beyond gender and race. So in our particular setting, we took data from 105 students and split them into 22 teams with a mix of males and females. But because the students are coming from computer science, this is a male-dominant class. So we had only 15 females and 1 non-binary, and then 3 people chose not to answer. And then there's also 63 racial minorities and 42 European descents. So we mixed all the racial minorities into one category because there's just too many sub-racial categories. So we wanted to see if they would collectively show anything in terms of consistent behaviors. And then there's also in total 11 racialized gender minorities. Okay, so say from the Canadian context, like I would be an example of a racialized gender minority because I'm female and I'm Asian. Okay. So a team, we define a team to be diverse for a certain learner characteristic if at least 2 members differ in their particular values. So in total, in this class of 105 students in these 22 teams, 12 of them are gender diverse, 10 are all male teams because we're in computer science. We also looked at specifically in terms of race. So we had 16 racial diverse teams versus 6 racially homogeneous teams. And among these 6, 1 was all white males, whereas all European descents, and 5 were all racial minorities. Okay. And then 8 teams in total had at least one racialized gender minority, whereas 14 other teams did not. So with these combinations, I won't go through this code book, but we took all the data because when you are doing code reviews with each other, you're looking at the code that they are writing, and then you can asynchronously write back and say, okay, well, this part looks good, or this part doesn't look good, you have to fix this, or this part needs to be changed in a certain way. And so we did a qualitative analysis on the data, on the communication data into these 18 different codes. And we were just looking at the general patterns that we are seeing in this data. Okay. And so what we did with that data was we used epistemic and network analysis to try to gain some insights about the general patterns of the communication behaviors. So epistemic network analysis, DNA, is a particular technique in quantitative ethnography to look at patterns and relationships in the data. So in this particular case, if you think about all the words and all the codes that we gathered from the code review, what it's doing is actually looking at all the words and patterns in terms of the vector space. So it's using this mathematical framework to look at how similar these codes are to each other and how similar the teams are communicating with each other from other teams, okay? So because it's using this high dimensionality vector space, it also uses something like a type of machine learning that compresses down the high dimensionality into 2 space, into like an XY dimension that we can reason and see more visually from human eyes, right? So here what this space actually shows is that all the black dots are the codes that I showed you from the previous code book. And the red dots are the teams, okay? So if you can think about in this particular space, we can actually start to think about like how close each dots are to each other, okay? So now the red dots are these teams. These 2, for example, are closer to each other, which means that these two teams communicate very similarly to each other. In contrast to say like this team out here to this team out here, because they are further apart, they communicate in more differently from each other. Okay. In the same space, you can think about the black dots in a similar way. So this is about like the suggesting behavior, like, oh, I think you should change this part of the code. I think you should change the way this code is written. Okay, these are suggestions. Or encouraging behavior, which is, oh, this looks great. I think this is a great way to try this approach, and I think this is a really good solution. There's also just general, you can see like the size of these dots will also show you that this type of behavior is done very often. So this is approving shallow, where people are looking at each other's work and they're just approving it. Yes, this looks good without any reason. And you may suspect all they're saying is looks good to me, right? So they're not really giving good reasons or good context as to why they're merging the work. Maybe they're just not wanting to review it seriously. Okay. We also saw some that are approving in context, okay, but you can see sort of the size of this node is much smaller. So the size of these nodes indicate the frequency. This dot here, for example, is boosting team morale. It's small, so it happens, but not very frequently. But basically, some team members are actually saying, "Yay, way to go, team!" Right? So they're actually trying to increase that team morale and be very supportive. When there's a line between these two nodes, for example, these two black nodes, the lines represent the co-occurrence of these codes in the same conversation. Okay, so that means that a lot of times when they are approving shallow, like approving someone else's work in a very shallow way, they're also complimenting because this line is very thick. So, they might say something such as, this work looks great. So there's complimenting, but they're not really saying much more about why it looks great. As opposed to say like this line is very thin. So they're, approving the work in a shallow way, and they like sometimes make this suggestion as to, this looks great, like, okay, this looks good to me, but maybe you want to change the indentation or something simple, right? So this is how we interpret this graph. And that's the general patterns that we saw. One of the things that we did was we took the gender diverse teams and we looked at their interaction patterns and we contrasted to the all male teams, and then we looked at their interaction patterns. Okay. And what we found was quite interesting. We took the difference between these two sets of teams. So that's one of the other things that's really cool about the ENA approach, is that the mathematical framework also allows us to take the difference between multiple groups and look at the stronger networks. Because if you created a network with just the gender neutral teams, with just the gender diverse teams and then with the gender homogeneous teams, the networks look very similar. So we basically took a subtraction of them to see which ones is group one more stronger in and which ones is group two stronger in. And so what you're seeing here is that all the blue lines indicate that these are the relations that are much stronger for the gender diverse teams. And the red lines, these are the relations that are much stronger for the all male teams. Okay, so we can focus in more on the differences between the two groups of teams rather than trying to look at everything at once. Okay, so what we're actually seeing is that gender diverse teams are stronger in terms of the social relational communication, right? So we can see things about emoting, expressing opinions. We can also see criticizing, which raises some questions as to who's criticizing who, because this is happening more often in gender diverse teams. And we go back to the literature about how gender diverse teams, like females tend to suffer from criticism from male colleagues quite a bit in the professional settings. This might also be something that we're seeing in the student setting. So we have to look deeper into the individual level as to who's criticizing whom. And because of this blue, it's also saying that it's not coming up nearly as often for the male teams. Okay. All male teams, on the other hand, are stronger in approving in context, like, why this is working well, why this is good work, why this is, should be accepted. They tend to be stronger in agreeing with each other, expressing their own opinions, and updating the work. So these are the ones that they are much stronger in, and also complementing each other. But these tasks, these codes relate to more task-oriented communication. Okay, so those are the differences that we're seeing, which we thought was actually quite interesting. We tried to look at race, racial diverse, and racial homogeneous data, and we actually did not see anything statistically significant. Okay, so what we did was now we looked at the intersectionality of these two. So we looked at gender and race together, and we're actually seeing a little bit of a difference. And so here, the red teams, so non-intersectional teams, are stronger in most of these patterns, but specifically in showing not task-oriented patterns, while they're actually doing more complementing as well. The intersectional teams, like the blue ones, they are actually stronger in only these two. They're showing stronger connections for criticizing, approving shallow, and updating. So because this is actually, like criticizing is actually showing up again, we're also curious just to check into it to see whether the criticizing that was coming up in the gender diverse teams was due to the intersectionality of these members. We don't actually know this yet, so this is only the team level data that we are seeing, and we're going to look deeper into the actual specific relationships with the individuals. So sort of stepping back, when we think about this in terms of how people interact with each other in terms of like the sociology of teams, there's a theory called categorization and elaboration model. And what this model does is it actually postulates that information elaboration, when we're actually talking about information and how things work, that is a core process between diversity and performance. So with all the different conflicting information about whether diversity is good for performance, we actually found that as this model postulates that one of the underlying processes that makes diversity work well is if they can actually support information elaboration. But there's some intermediate moderators that may impact the outcome. So one is member motivation. If you're not motivated, you're never going to have very good performance. Member ability, task complexity, and the other thing is intergroup bias. And so what intergroup bias means in this context is that within a team, you may have subgroups that form. And so imagine a gender diverse teams. You might have the boys group against the girls kind of thing, right? And so then you can potentially form subgroups. And so if that happens and there's biases about each other, you can actually have negative performance within the team, okay? So the presence of intergroup bias may surface as conflict among the group members within the team due to the relationship conflicts and class and task conflict. And so if that's the case, we might be able to think about communication as a way to resolve conflict. And so maybe if gender diverse is actually creating more of these intergroup biases problems, that's probably why we're seeing that there's more communication behavior attended to resolve some of these relational conflicts that we saw earlier in those patterns. So that's one of the hypotheses that came out of the study. We saw that race alone, again, was not a salient factor to the student software teams, at least in our Canadian context. And this might be because if you look at our student population, it's quite diverse in terms of race. And so we have about like 40% international students with different race. However, if you look at the gender, in terms of the student population, in terms of gender, there's only 17% females. So we're still quite the minority, and maybe that's why there's some issues there still. So gender diverse team patterns suggest the presence of intergroup biases I explained earlier. And of course, we have to look at some of these details at the student level just to understand what's going on exactly. So going back, just to wrap up, this was the picture that I showed earlier in terms of where team formation fits in terms of the overall teamwork process. And so far we've looked at how teachers can be the audience of learning analytics. And so there's one aspect where we're looking at supporting the teachers in diagnosing team compositions, and then another aspect which is looking at the use of peer evaluations, which can then be used to do future team regenerations. Okay. Currently, we're actually exploring how different instructors may trust AI-generated teams for classroom use and how that plays a factor in how we can actually support that work in process. The other aspect that we're looking at is here where students are now, are the audience of the learning analytics process, where we're trying to support ongoing team monitoring. And so far, I've shown some of the work that we started here, and we're actually interested in looking more deeply at student level communication patterns so that we can detect at-risk behaviors and alerting the instructors to potential problems that may come up. And so that's it, and that's sort of the summary of where we're at today. And so hopefully this talk, gave you some insights on sort of the work that we're doing, and thank you for having me here.
Thank you, Dr. Bowen. And so I think there's a lot of takeaway and definitely a lot of technical aspect in this design. And so how, I guess my first question for you before I ask others to think about is, like, how those educators could take away from this talk and be able to apply into their classroom design and supporting the students' learning?
Yeah, I think that's a really great question. So I come from the computer science background, so we're looking at things in a very technical way. And we're trying to provide better support for educators, but it really feels like we're very far away, which explains why there's so many case studies out there to try to support what we should be doing and how we should be building these approaches to do some things more automatically or at least assisted by technology. So I think there is a lot of theory out there that we can borrow from. There's a lot of patterns and a lot of knowledge and case studies that we can use. It's just hard to generalize because there's so many different pockets of knowledge everywhere. So engineering has their own theories and terminology, sociology has their own theories and terminology, education. So I think we still need a lot more synthesis in the literature. But in the meantime, I think all we can do is just keep trying to figure out what works best in our individual case studies. And if something doesn't work or the literature reports certain conflicting results, it may just be because that their scenario is a little different. And I think that's an important thing to remember is, even when we talk about diversity, a lot of people say, oh yeah, diversity is great. And then everyone kind of jumps on and say, yes, it's great. But actually, sometimes we have to think more beyond diversity, right? Like we have to not just put them in diversity, so we have to support them in an inclusive way. And also, as an example, we do capstone projects, which means we have projects that have external clients involved. And diversity, one of the catch with diverse teams is that they may work well in terms of very innovative thinking and solution problem solving and things like that. But it takes time for them to form and norm and perform, right? So the problem is that if you have a certain time frame and you have these external clients and you need to keep up a certain reputation, you have to be very careful about, okay, what's more important today? Is it trying to make sure the clients have their goals satisfied? And so maybe the teams will need to be formed slightly differently. Maybe the time frame of the project doesn't really support this diversity, the diverse teams to work together quite yet, but maybe it does, right? So we have to, I think, consider multiple dimensions when we're actually building these teams and thinking about how we should form the teams and work with them.
Thank you. All right, so let's see whether anyone online and also those who are here, any particular questions from the online audience as well. Maybe you can type in the test box, see whether there's any message there. Okay.
I think it's fine.
Yeah. Right. So if not, maybe for those who are still thinking about these topics and would like to have further discussion, and they can feel free to email you, and also to extend the further discussions of the work or meeting you at the different conferences. So I guess that's it for today. And if you don't have any other questions, and let's give another thank you to Dr. Boyce for her visits. Thank you.
Thank you.
Thank you very much.